A bridge costing $400 million just snapped. But it wasn't a freak accident, it was a fatal design flaw. Engineers prioritized cost-cutting over structural integrity, selecting a brittle alloy that couldn't handle simple thermal expansion. Discover how one tiny material choice turned a modern marvel into a catastrophic disaster overnight.
0.4 seconds. That is the exact duration between structural integrity and total kinetic dissolution. $400 million of pre-stressed concrete and steel vaporized before the first alarm sensor could even register a vibration. We aren't looking at a collapse. Elena, gravity doesn't work this fast on its own. This was a structural execution. The bridge didn't just fall into the river. It was violently rejected by the laws of physics.
Rejected by the laws of economics. Mark, look at the timestamp on the failure log. 4 a.m., the lowest traffic volume of the week. This bridge wasn't killed by a heavy load. It was killed by a spreadsheet error made 3 years ago. Do you know what the burn rate is on a disaster of this magnitude? We just lost the GDP of a small island nation in under a second. Every piece of debris floating down that river represents a lawsuit that will bankrupt the state's infrastructure fund for the next decade. This isn't just a tragedy. It is a fiscal black hole opening up in real time.
Forget the money for a second and look at the shear pattern on the main span. That is terrifying. Steel is supposed to be ductile. It's supposed to warn you. It stretches, it groans, it yields, it screams before it dies. This was silent until the moment of detonation. The energy stored in those cables, millions of joules of potential energy, didn't dissipate slowly. It converted to kinetic shock waves instantly. The sound alone shattered windows a mile away. That tells me the material didn't fail in the traditional sense. It shattered. It behaved like glass, not steel.
Because someone treated the material specification sheet like a menu with optional pricing. I'm pulling the procurement logs right now. They saved, what? A fraction of a percent on the alloy composition? They swapped a specific, high-grade ductile steel for something that looked identical on paper, but cost 20 cents less per pound. Multiply that by 40,000 tons, and someone got a nice bonus for cost optimization. They traded the ductility you're talking about for a short-term budget win. They bought a discount bridge mark, and now we are paying the compound interest on that stupidity.
The physics of that discount are brutal. You're talking about brittle fracture. At low temperatures, standard steel gets tough. But this imposter alloy turned into a ceramic the moment the thermometer dropped. The bridge was fighting itself. As the temperature fell last night, the metal tried to contract. It's a natural thermal reaction, but the constraints held it tight. The internal tension spiked. 200, 300, 400 megapascals, pulling apart the molecular bonds from the inside. There were no trucks, no wind, no earthquake, just the cold air and a metal that was too cheap to handle it.
And that's the negligence, the value engineering clauses. I've seen this before. A project manager, under pressure to deliver under budget, looks at the safety factor of 2.5 and thinks, we can trim that to 1.8 and save $3 million. They slice away the margin of error to pad the bottom line. But infrastructure doesn't negotiate. You can't bribe thermal expansion. Now, instead of a $3 million saving, we are looking at a $2 billion cleanup. The logistics alone, cranes, divers, forensic engineers, will cost more in the next week than the original savings generated in the entire project lifespan. It's the most expensive way to save money I have ever seen.
It's not just the cleanup, it's the energy release. When that main cable snapped, the whiplash effect was supersonic. It sliced through the concrete deck like a hot knife. We are lucky it was 4 a.m. If this had happened during rush hour, the kinetic energy transfer would have turned vehicles into projectiles. The bridge didn't just fail to support them. It would have actively attacked them. We are looking at a forensic nightmare. We have to distinguish between damage caused by the fall and the microscopic fractures that caused the fall. But I can tell you right now, looking at the grain structure of that exposed beam on the monitor, that is not the steel that was specified in the blueprints. That is a imposter.
It's a counterfeit asset. They paid for reliability and took delivery of a catastrophe. The insurance adjusters are going to have a field day. They will trace the serial numbers on those beams back to a foundry that probably doesn't even exist anymore, or operates under a shell company to avoid liability. This creates a supply chain crisis for the entire region. That bridge carried 40% of the commercial freight for the tri-state area. The supply chain just snapped along with the steel. The economic ripple effect is going to starve factories and empty shelves within 48 hours.
And the terrifying part? The physics didn't change. The load didn't change. The only variable was the temperature. A 5-degree drop was the difference between a standing structure and a debris field. That's how close to the edge they were running. They built a structure that could survive a hurricane, but couldn't survive a chilly Tuesday morning. It highlights the absolute arrogance of ignoring material science. You can fake the paperwork, Elena. You can fake the inspection reports, but you cannot fake the atomic bond strength of iron and carbon.
They bet against the cold, and the house won. Now every other bridge built by this consortium is suspect. We aren't just investigating a collapse, we are auditing an entire era of construction. If they cut corners here, where the stakes were $400 million, imagine what they did on the smaller projects. This isn't an isolated incident, Mark. It's a symptom of a systemic infection in the industry, where on time and under budget is valued higher than won't kill you.
Well, the autopsy begins now, and the first cut is going to reveal that this wasn't an accident. It was inevitable. The moment that brittle alloy was poured into the mold, the clock started ticking. We just happened to be here when it hit zero. We need to zoom in, not to the bolt or the beam, but to the atomic lattice itself. To understand why this bridge didn't just sag but actually snapped, you have to understand the fundamental betrayal of the material. The original blueprint specified ASTM A709 Grade 50W weathering steel. It's the industry standard for a reason. It has a specific microstructure that allows for what we call plastic deformation. Imagine bending a paperclip. It bends, it stays bent, but it holds. It warns you before it breaks. It absorbs energy. That is ductility. It is the forgiveness factor in engineering.
And forgiveness is expensive. Grade 50W steel requires specific alloying elements: copper, chromium, nickel. These aren't cheap additives, they are commodities with volatile market prices. When the budget crunch hit phase 3 of construction, the price of nickel had spiked 30%. I found the change order request. Mark, it's dated 18 months ago. They switched the specification to a functionally equivalent structural steel imported from a supplier that specializes in agricultural equipment, not critical infrastructure. They saved roughly $400 per ton on a 40,000-ton structure. That's a $16 million swing on the balance sheet. That's the number that killed this bridge. $16 million in savings that just cost us the entire logistics corridor.
Functionally equivalent is a lethal phrase when you don't understand the physics of cold. The substitute steel, likely high in carbon and low in the stabilizing alloys you mentioned, has high tensile strength. It's strong. It can hold a lot of weight, but it has an Achilles heel: the ductile-to-brittle transition temperature, DBTT. Good steel stays tough even at 40 degrees below zero. This cheap alloy, its transition point was likely right around freezing. Last night, the air temperature hit 28 degrees Fahrenheit. At that exact thermal threshold, the steel underwent a phase change. It stopped acting like a metal and started acting like a ceramic. It lost its ability to absorb shock.
And the documentation proves they knew about the risk, but they managed it with paperwork instead of science. I'm looking at an email thread between the lead structural engineer and the project manager. The engineer flagged the DBTT issue. He explicitly stated, this material lacks the toughness certification for Zone 2 climate conditions. Do you know what the response was? It wasn't a stop work order. It was a request to reevaluate the climate data to justify the variance. They didn't change the steel to match reality. They tried to change the reality to match the budget. They shopped around for a risk analyst who would sign off on a warmer weather model to make the cheaper steel acceptable on paper.
So they effectively legislated away the winter. But thermodynamics doesn't read risk assessments. Here's the mechanics of the snap. As the bridge cooled down overnight, the steel tried to contract. For every 100 feet of bridge, the metal wanted to shrink by about ½ inch. That doesn't sound like much, but when you have a continuous span of 2,000 feet, you are talking about 10 inches of movement. The expansion joints were designed for the original, flexible steel. This stiffer, brittle substitute didn't glide. It locked up the friction, and the bearings increased. The tension built up inside the girders like a coiled spring.
This is where the sunk cost fallacy turned fatal. By the time the steel arrived on site, the project was already 6 months behind schedule due to permit delays. Returning the steel would have meant a further 6-month delay and millions in penalty clauses, so they installed it. They chose to bury the error in the concrete rather than take the financial hit of correcting it. It's a classic decision matrix failure, prioritizing schedule adherence over functional viability. They treated the bridge as a project to be finished, not a structure that had to stand. The completion bonus for the executive team was tied to opening before the fiscal year-end. That bonus structure incentivized them to ignore the engineer's warning.
And that ignored warning manifested as a micro crack, probably started at a weld point or a bolt hole, a stress concentrator. In ductile steel, the material around the crack would yield, blunting the tip of the crack and stopping it. But in this brittle nightmare, the crack didn't blunt, it sharpened. Under the thermal tension of the cold night, that microscopic flaw accelerated to the speed of sound. Literally, we call it rapid crack propagation. It travels at thousands of feet per second. One bolt failed, shedding its load to the next. The next bolt, already maxed out by the thermal contraction, snapped instantly. It was a zipper effect, unzipping the structural integrity of the entire main span in the blink of an eye.
From a forensic accounting perspective, this creates a fascinating liability loop. The supplier provided exactly what was ordered in the revised purchase order. They are technically off the hook. The fault lies entirely with the design firm that approved the substitution and the construction consortium that pushed for it. We are going to see a battle of insurance giants. But the real cost is the hidden inflation. Every bridge built in the next 5 years will cost 20% more because inspection protocols will triple. The insurance premiums for infrastructure projects will skyrocket. This one failure has just raised the cost of doing business for the entire construction sector.
The tragedy is the invisibility of it. If you looked at that bridge yesterday, it looked perfect. The paint was fresh, the lines were straight, but inside, at the granular level, the crystals were aligned for failure. It's the ultimate deception of bad material science. It works perfectly until the exact second it doesn't. We rely on safety factors, building things 3 times stronger than they need to be. But brittleness nullifies safety factors. A brittle material doesn't care if it's thick or thin. Once the crack starts, the geometry doesn't matter anymore. Physics takes the path of least resistance, and last night, the path of least resistance was through the support beams, dropping 4 lanes of highway into the dark water.
The dawn breaks over a disaster site, but the real hemorrhage is invisible. It's bleeding out through the fiber optic cables of the stock market. The logistics companies that relied on this bridge operate CAM just-in-time delivery models. They don't have warehouses anymore. The trucks are the warehouses, and right now, 4,000 warehouses are idling on the wrong side of the river. We are calculating a supply chain disruption cost of $40 million per hour. The factories on the South Bank are shutting down assembly lines as we speak because the parts they need are stuck on the North Bank. This isn't just a traffic jam, it's a regional cardiac arrest. The dawn breaks over a disaster site, but the real hemorrhage is invisible. It's bleeding out through the fiber optic cables of the stock market. The logistics companies that relied on this bridge operate on just-in-time delivery models. They don't have warehouses anymore. The trucks are the warehouses. And right now, 4,000 warehouses are idling on the wrong side of the river. We are calculating a supply chain disruption cost of $40 million per hour. The factories on the South Bank are shutting down assembly lines as we speak because the parts they need are stuck on the North Bank. This isn't just a traffic jam, it's a regional cardiac arrest.
While the economy flatlines, the forensic engineering team is conducting the most expensive autopsy in history. They are down there in the water now, cutting samples from the wreckage. They aren't looking for survivors anymore. They are looking for chevron marks. When steel snaps in a brittle fashion, the crack leaves a roadmap on the face of the metal, V-shaped patterns that point backwards, straight to the point of origin. It's nature's way of pointing a finger at the guilty party. And the divers just found it, primary girder C4. The fracture surface is bright and granular. That's the smoking gun. Ductile breaks are dull and fibrous. Brittle breaks sparkle. That sparkle is the evidence of criminal negligence.
And that evidence is going to pierce the corporate veil. The consortium that built this will declare bankruptcy by Friday to protect their parent company's assets. It's a standard defensive maneuver. They will try to blame the inspection firm. The inspection firm will blame the steel supplier. The supplier will blame the raw ore specifications. It's a circular firing squad of liability. But the forensic audit I'm running tracks the money, not the steel. We found the value engineering proposal approved 2 years ago. It's a single-page document. It lists the material substitution as a low-risk, cost avoidance measure. Someone actually typed those words. They assessed the risk of catastrophic failure as negligible because they used historical weather data that ended in 2010, conveniently ignoring the recent polar vortex trends.
That's the arrogance of static data in a dynamic world. The lab results from the recovered debris just came back. The Charpy V-notch test. It measures toughness. It measures how much energy a material can absorb before snapping. The spec required the steel to absorb 25 foot-pounds of energy at 0 degrees. The sample from the river? It absorbed 4. It didn't just fail the test. It didn't even show up. A standard household hammer could have compromised that girder under the right thermal conditions. We built a monument to human achievement out of rock candy. The engineering lesson here is going to be written in blood. You cannot test for ductility with a calculator. You have to physically punish the material to know the truth.
The fallout from this will rewrite the ASTO, American Association of State Highway and Transportation Officials, codes for the next 50 years. Just like the Hyatt Regency walkway collapse changed connection design, and the Tacoma Narrows changed aerodynamics, this disaster will end the era of generic material specification. The cost of building a bridge is about to go up by 30% globally. Mandatory independent metallurgical testing for every single heat of steel. No more relying on manufacturer certificates. We are moving from a trust but verify system to a verify or condemn system. The cheap bridge era is dead. It died this morning at 4 a.m. along with this structure.
It's a painful evolution. Engineering codes are reactive documents. They are a catalog of things we learned not to do. We thought we had mastered steel. We thought the days of brittle fracture were left behind in the Liberty ships of World War. But we got complacent. We let the accountants drive the material science. The replacement bridge they build here will be a fortress. It will use grade 70 high-performance steel. It will have redundancy upon redundancy. It will be ugly, heavy, and expensive, but it will stand. Because now we know that the price of elegance cannot be paid by skimming the budget on the atomic lattice.
The irony is suffocating. To save $16 million, they have incurred a total economic loss that will exceed $2 billion by the time the lawsuits are settled and the new span is open. If you had walked into that boardroom 3 years ago and told them, spend the extra money or lose $2 billion, they would have laughed you out of the room. They would have called you an alarmist. That is the fundamental flaw of the financial mind. It discounts low probability, high-impact events to zero. They assume unlikely means impossible. But in a project with a 100-year lifespan, unlikely eventually becomes inevitable.
And physics is the only auditor that matters. It doesn't care about your quarterly earnings or your bonus structure. It tests your work every single second of every single day. Gravity is relentless. Thermal expansion is relentless. The moment you stop respecting the materials, the countdown begins. This bridge didn't snap because of a mystery. It snapped because we forgot that civilization is just a thin layer of processed metal holding us up above the chaos. And when you buy the cheap metal, you invite the chaos in.
Case closed. The file is sealed, but the debt remains.